In an era where rapid information consumption often overshadows deep learning, a recently highlighted cognitive technique known as the 10-minute rule is garnering attention for its simplicity and effectiveness in enhancing memory retention and recall. This method, which advocates for brief focused learning sessions followed by short breaks, offers a fresh perspective on how individuals can optimize their learning processes with minimal effort. Research suggests that our brains are not designed for extended periods of intense focus. Cognitive scientists have long argued that the ability to absorb and retain information diminishes significantly after prolonged study sessions. The 10-minute rule counters this by breaking down learning into digestible chunks, promoting a more efficient and less taxing approach to acquiring new knowledge. By engaging in concentrated learning for just 10 minutes followed by a brief pause, learners can reinforce their understanding and improve recall. Dr. Emily Carter, a cognitive psychologist, explains the science behind this technique. When we focus intensely for a short period, we create stronger neural connections that are essential for memory formation. The subsequent break allows our brain to consolidate information, making it easier to retrieve later. This insight aligns with the broader understanding of how spaced repetition and active recall contribute to effective learning. The implications of the 10-minute rule extend beyond academic settings. Professionals in various fields, particularly those in fast-paced industries, can benefit significantly from this method. For instance, employees juggling multiple projects may find that dedicating just 10 minutes to learning a new skill or reviewing important material can lead to enhanced productivity and reduced stress. Moreover, as workplace dynamics evolve, fostering a culture of continuous learning becomes paramount. And strategies like the 10-minute rule can facilitate this transition. Quantifiable results from studies reinforce the effectiveness of this approach. A recent study conducted by researchers at Stanford University found that students who utilized the 10-minute rule exhibited a 20% improvement in information retention compared to those who engaged in traditional hour-long study sessions. This data underscores the potential for the 10-minute rule to transform learning methodologies across educational institutions and corporate training programs alike. As this cognitive technique gains traction, experts encourage individuals to integrate it into their daily routines. Whether it involves mastering a new software tool, preparing for presentations, or simply enhancing general knowledge, the 10-minute rule offers a flexible framework for learners of all ages. Encouragingly, many educational platforms and apps are beginning to incorporate this methodology, suggesting a shift toward more user-friendly learning environments. Looking ahead, the growing recognition of cognitive science principles in everyday learning practices points to an exciting future for educational strategies. As more people embrace techniques like the 10-minute rule, we may witness a significant transformation in how knowledge is acquired, retained, and utilized. The focus will likely shift from sheer volume of information to the quality of understanding, allowing learners to thrive in an increasingly complex world. In an era marked by swift advancements in technology and science, the importance of remaining vigilant and appreciative of these developments cannot be overstated. As society continues to grapple with complex health challenges and the implications of scientific research, it becomes crucial to remember that progress is not guaranteed. A recent guest commentary in the Baltimore Sun emphasizes this notion, urging readers to recognize and support the scientific endeavors that shape our future. The commentary highlights the potential consequences of taking scientific progress for granted, particularly in the context of public health. As the world emerges from the shadow of the COVID-19 pandemic, the role of mRNA technology has been thrust into the spotlight. This innovative approach, which underpinned the rapid development of vaccines, has demonstrated its efficacy and safety, paving the way for new treatments for various diseases. The importance of such advancements is underscored by the recent approval of a new vaccine employing mRNA technology for individuals over 60, a demographic that has shown heightened vulnerability to numerous health threats. In addition to the positive strides made in vaccine development, the discourse surrounding mRNA technology has also sparked significant debate. Governor Ron DeSantis and First Lady Casey DeSantis have called for a permanent ban on mRNA mandates. a move that they argue is essential for protecting patient freedom. Their position reflects a growing concern among some groups regarding the intersection of public health policy and individual rights, illuminating the delicate balance between collective safety and personal autonomy. As the scientific community continues to innovate, new tools are emerging that aid in furthering our understanding of complex biological processes. A notable development is a new toolbox designed for characterizing internal ribosomal entry sites in cells. This advancement promises to enhance our grasp of gene expression and regulation, with implications for a variety of fields including cancer research and genetic disorders. The impacts of these scientific advancements are profound. They not only contribute to our understanding of health and disease but also inform public policy and shape societal attitudes toward science. As we navigate this intricate landscape, it is essential to foster a culture that values scientific inquiry and promotes informed discussions. Looking ahead, the trajectory of scientific progress remains uncertain. While recent innovations illustrate the potential for transformative change, they also serve as a reminder of the responsibility we bear in supporting and advocating for science. As stakeholders in this ongoing narrative, it is imperative that we remain engaged, informed, and appreciative of the remarkable achievements that continue to emerge from the scientific community. The future of health and technology hangs in the balance, and our collective actions today will undoubtedly shape the world of tomorrow. In a groundbreaking study, researchers have established a significant correlation between the consumption of sugary sodas and an increased risk of developing cancer. Published on March 23, 2025. This research adds to a growing body of evidence linking dietary choices with long-term health outcomes. The findings are particularly alarming as they highlight yet another potential health hazard associated with the ubiquitous presence of sugary beverages in modern diets. The study, which involved extensive analysis of dietary habits and health outcomes, found that individuals who consumed high quantities of sugary sodas were at a markedly higher risk of certain types of cancer. Our findings suggest that the sugars and additives present in these beverages may play a role in cancer development, said lead researcher Dr. Emily Cartwright. This assertion is supported by data that indicates a direct relationship between the frequency of soda consumption and the incidence of various cancers. One of the most concerning aspects of this research is its implications for public health policy. With sugary soda consumption already linked to obesity, diabetes, and heart disease, the addition of cancer to this list could catalyze a shift in how these beverages are marketed and regulated. Experts have long recommended reducing sugar intake, but this study could provide the impetus for more rigorous legislative measures aimed at curbing sugary drink consumption. This research reinforces the need for comprehensive health campaigns that address the dangers of sugary drinks, stated nutritionist Dr. Sarah Kim. The impact of these findings extends beyond individual health choices. They pose significant questions for industries that manufacture and sell sugary sodas. This study arrives at a time when consumers are becoming increasingly health-conscious, prompting a growing demand for healthier alternatives. Companies may face pressure not only to reformulate their products but also to be more transparent about the health risks associated with their offerings. As the discussion around sugary sodas and their health implications gains momentum, it is essential to consider the broader context of dietary behavior and lifestyle choices. The increasing prevalence of processed foods and beverages high in sugar has already contributed to a public health crisis characterized by rising obesity rates and associated chronic diseases. The findings of this recent study serve as a crucial reminder of the interconnectedness of diet and health outcomes, urging individuals and policymakers alike to prioritize nutritional literacy and healthful eating habits. Looking ahead, the research community anticipates further investigations into the specific mechanisms by which sugary sodas may contribute to cancer development. Understanding these pathways could lead to more targeted public health interventions and educational initiatives aimed at reducing consumption. As we continue to uncover the links between diet and health, it is clear that awareness and action are critical in combating the rising tide of chronic diseases, including cancer. In recent years, The intersection of artificial intelligence (AI) and scientific research has sparked significant debate and excitement within the global scientific community. As AI technologies evolve, they are increasingly being integrated into diverse fields from crop breeding to linguistics, dramatically altering the landscape of traditional research methodologies. This shift raises important questions about the future of scientific discovery, the role of human researchers, and the ethical implications of AI-driven advancements. One notable instance of AI's impact on scientific discovery is the use of AI in crop breeding, as highlighted by recent reports from Chinese scientists. These researchers are leveraging advanced AI algorithms to enhance crop yields and improve the quality of various agricultural varieties. By analyzing vast datasets, AI can identify optimal breeding strategies that would take human researchers significantly longer to uncover. AI can process information at a scale and speed that is simply beyond human capability. One researcher noted, emphasizing the technology's potential to address global food security challenges. Simultaneously, the migration of top AI talent has become a pressing issue, particularly with the recent departure of AI expert Guojun Shi from the United States to China. This move not only reflects the growing allure of opportunities in China's burgeoning AI ecosystem, but also underscores the increasing competition between nations to harness AI for scientific and technological advancements. As Guojun Shi stated, the environment for AI innovation in China is incredibly dynamic and supportive, offering unique resources and collaboration opportunities that are hard to find elsewhere. This trend could potentially reshape the balance of power in AI research and development, with implications for global collaboration and competition. In a different sphere, the integration of AI into language sciences is making waves in India, where political considerations intersect with technological advancements. With the Indian government increasingly prioritizing AI development, researchers are exploring how AI can enhance linguistic capabilities and promote inclusivity among India's diverse population. This initiative not only aims to streamline communication but also aspires to preserve and promote regional languages that risk being overshadowed by dominant languages. As one scholar noted, AI offers us tools to amplify voices that have been historically marginalized, creating a more equitable linguistic landscape. As these developments unfold, the potential of AI to revolutionize scientific discovery is becoming increasingly apparent. However, this shift also invites scrutiny regarding the ethical implications of AI-driven research. Concerns about data privacy, algorithmic bias, and the devaluation of human expertise are at the forefront of discussions among scientists and ethicists alike. The challenge will be to strike a balance between harnessing the power of AI and ensuring that human values and ethics remain central to scientific inquiry. Looking ahead, the trajectory of AI in science appears poised for further acceleration. The ongoing advancements in machine learning and data analysis promise to unlock new frontiers in research, but they also necessitate a thoughtful examination of the implications for society at large. As the scientific community grapples with these challenges, the collaboration between human intelligence and artificial intelligence will likely define the future of discovery, shaping not only the landscapes of technology and research but also the ethical frameworks that govern them. The coming years will undoubtedly reveal how well humanity can navigate this transformative era in scientific exploration. In a groundbreaking discovery that reshapes our understanding of the universe, NASA's James Webb Space Telescope JWST has identified the oldest known oxygen in an ancient galaxy, pushing the boundaries of our knowledge about cosmic evolution. This remarkable finding, published on March 23, 2025, underscores the telescope's capabilities and the potential for significant advancements in astrophysics. The oxygen detected by the JWST was formed through nuclear fusion in stars, a process that has been fundamental to the creation of elements necessary for life as we know it. The galaxy in question, observed by the JWST, dates back to a time when the universe was merely a few 100 million years old. This discovery provides crucial insights into the early conditions of the universe and the formation of galaxies during what is often referred to as the cosmic dawn. Dr. Jane Holloway, a lead researcher on the project, emphasized the importance of this finding, stating, "This is a monumental step in our quest to understand the early universe." The presence of oxygen so early in cosmic history suggests that stars were forming and evolving far more quickly than previously thought. This revelation aligns with recent theories proposing that the universe underwent significant changes in its formative years, including rapid star formation and elemental synthesis. Data gathered from the JWST indicates that the galaxy's oxygen levels are remarkably high, suggesting a complex interplay of cosmic events shortly after the Big Bang. The implications of this oxygen discovery extend beyond mere chemical composition. They hint at the potential for life-supporting environments in the primordial universe. Scientists are now re-evaluating models of galactic evolution that previously underestimated the timeline for the emergence of essential elements. The JWST's advanced technology, including its ability to observe in infrared wavelengths, has allowed astronomers to peer deeper into space than ever before. This capability has opened new avenues for exploration, paving the way for future missions aimed at uncovering the mysteries of the universe's earliest epochs. As the scientific community digests this data, it is clear that the journey of understanding our universe is far from over. The discovery of ancient oxygen not only enriches our knowledge of the cosmos but also sparks curiosity about other primordial elements that may have formed in similar conditions. Researchers are eager to explore the implications of these findings further, particularly in regard to the origins of life. In conclusion, the James Webb Space Telescope's detection of the oldest known oxygen in an ancient galaxy marks a pivotal moment in astrophysics, providing a clearer picture of the universe's early years. As scientists continue to analyze this data, we can expect a multitude of exciting developments in our understanding of not just oxygen and life-sustaining elements but also the broader mechanisms that shape the cosmos. The quest for knowledge is ongoing, and with each discovery, we inch closer to understanding the profound complexities of our universe.